All right, so this video is, I believe, 4.2a. It's the slope of a line. That's what we're kind of dealing with today. So 4.2a, the slope of a line. And we're going to talk about slope as a rate of change. So your note paper should say 4.2a on it, and that says slope of a line. Now, we'll start off with this this picture right here. I think it's pretty helpful. So we're at number 1 on this thing. And if we look here, we've got a couple of different things going on. We got a diagram that's showing the rate of change. So we want to see how these guys' height is changing, basically. So the diagram shows the side view of a ski lift. What is the vertical change from A to B? So what we should do is we should kind of focus on A and also B and find the change in height, like how high did they go. So A is here, right? And B is there. So, I mean, if A is at a height of 40, right? A is clearly at a height of 40. And B is over here. It's at a height of 50. It's on this grid line, right? There's B. What was the change in height? Well, the change in height from A to B, this, was 10 feet. So that's the first answer. Now they want to know the change in height from B to C. So the change in height from B to C, we'll use blue for C, and we'll still use green for B, obviously. Well, C is way up here, and C is at a height of 90. So if it went from a height of 50 to a height of 90, I believe that the change in height was 40 feet. It went up 40 feet. And then we want to know the change in height from C to D. We're running low on colors, so we'll use purple for that, and C will be blue again. So let's look at where D is. It's over here. And what height is that at?
Afternoon HS here. Afternoon announcements.
100, right?
Oranges and grapefruits for sale. Stop at.
So, like I was saying before I was interrupted by that young man on the intercom, we are looking for the change from C to D, and that's a height of 90 to a height of 100. So the change there from C to D is 10 feet. Now, you don't have to write this in the gray box. You can write this on the side. You know, it might be smart to kind of go over here and say it's 10 feet, the first question, and then it's a change of 40 feet, and then it's a change of 10 feet again. Okay, does that make sense? So that's where we're at here. Now we want to talk about horizontal changes. So same deal. We're going to look at the horizontal changes here. So what's the horizontal change from A to B? So should we continue to color code? Let's do it. A is red, B is green, the green point, C is the blue point, and D is the purple point, I suppose, right? The purple point. So there's that. So let's kind of look at this. I'm going to use the mouse. It's a little bit small, but it should be able to be visible because I can't really point with my finger while I'm recording here. So let's try this. You see the eraser there. From A to B, what's the horizontal change? So from A, it's at 20, you see that? And it ends up that B is at 50. So from 20 to 50, that's a horizontal change of 30. 20 to 50 is a horizontal change of 30. From B to C, it's at 50 here, between 40 and 60 is at 50, and then it's at 80. So that's a change of 30 as well. So we have two horizontal changes of 30 feet on this thing. So we have a change of 30 feet. That's the first question. Then we have a change of 30 feet. That's the second question. And then here from C to D, that horizontal change is from 80 to 110. That's also a change of 30 feet. So the answer to all of these is a horizontal change of 30 each time. That's basically what we're looking at. So as we carry on, we got to find the ratio of the vertical change to the horizontal change for each section of this ski lift. So the ratio of the vertical change to the horizontal change. So I don't really want to erase this. I want to kind of keep this information here because what I want to do is I had 3 answers each time, right? I had 3 different answers. And what I want to do is I want to take, and I'm going to have to use the same colors here. Maybe I can try orange or something. I want to take the vertical change and divide it by the horizontal change. So I want to take this change, the first one, from A to B, and divide it by the horizontal change from A to B. So that's going to be 10 feet divided by 30 feet. And I guess in that case it's just 1/3. That's our first answer on number 3. So let's just kind of keep going through that process. Can you find the next two answers? So we want to take this and divide it by this and get an answer. Then we want to take this and divide it by this, okay? I'm using the same colors, but it's not really as much related. So take the green and divide 40 by 30, take the blue and divide 10 by 30, and get your two other rates of change, I guess, your changes in y over change in x. And then I want you to answer question 4. So your now you tries right here, okay? And NYT stands for now you try. These are your now you tries. So I'm going to draw all over this because I can. And I'm going to say that these are now you try. So why don't you pause the video, think about what section's the steepest, which section's not steep, how did the ratio look in that, and give that a shot. So pause the video, and I'll see you in just a second. So I've moved on, and I'm now going to talk about the rate of change here. So I want to talk about the rate of change of this baby. This is a strange question. Probably wouldn't have seen this in algebra book a few years ago, but nowadays this is kind of an important question. So I guess what we should kind of think about is the time, right? I mean, if we look at birth, and we look at time as the independent variable, right? We say time is x. So let's let x equal time. Okay? And if we were going to say x1, like the time where we start, is 0. Why is that? Because we're at birth. We're at birth. So that's what we kind of look at here. Okay, so what we want to kind of think about, and I was kind of talking about this being the independent variable, x1 is 0, so at birth is 0 times 0. You could call x time, or you could just call it t if you wanted, an L. I mean, you could say that x is equal to t, and that's time, and y is equal to L, and that's length. And you could just write the equation like that if you want. But if x is t, then you got to make sure that it's change in time underneath change in length, right? So what was the change in length of this baby? And I kind of was, I guess I'm a little scatterbrained here because I started showing you one way and now I'm kind of thinking about this. I kind of like this. So instead of change in x over change in y, I'm saying x is time and I'm saying y is length. So now I'm doing change in length over change in time. Well, what was the change in length? This is going to be way better than doing a slope formula on this. The change in length was clearly 9 inches positive. It got longer, like the baby got taller, if we like to say, or I like to call it taller. It seems weird to say a baby got longer. So the baby got taller. That's how I'm going to talk about it. And it took 10 months. And we should talk about units here. We have 9/10, and it's inches and months. So isn't it 9/10 of an inch per month? That's the rate of change here. Look at this problem. Rewatch it if you need to. It's an important problem, okay? Okay, so with this next example, we want to talk about how to find the slope from like a table. So like if you think about a table is really just a bunch of points. Like I could look at this and I could tell you that this is an x and a y, so this is like 1, 8, right? Like this is what a table is. A table is just a whole bunch of points. 4, 6. Well, that's the point 4, 6, right? 7, 4. Well, that's the point 7, 4. I mean, that's what a table is. It's just a whole big list of points that go together. And 10, 2. Now, you don't have to write out all the points every time. That's fine. But you do want to know how to find the slope from a table. Like, you can do it a couple of different ways. I like to do change in y over change in x. But we don't need all this information. If the table is on a line, all we need to do is figure out the change in y here, which is +2 from here to here, and the change in x, which is -3. So the change in the y values was +2, and the change in the x values was -3. So that is the slope of this table. So whenever you're looking at a table, the slope of the table is just by finding change in y over change in x between 2 of the x's and 2 of the y's on the table. A table is just a whole bunch of points listed out. So what I want you to do is, even though it's not written on your paper, I want you to try this problem. I'm going to make a little table here, and I'm going to ask you to find the slope of the points on the table. So let's just check out, copy this table down, and give this a try. So copy this table down, take a second, and then I want to say the same thing. The points on this table lie on a line. Can you please find the slope of that line? The points on this table lie on a line. Find the slope of that line. So pause the video and give this a shot. Okay, so again, hopefully you paused the video and you've tried that. And I'm going to kind of like move on to the next problem. I'm not going to tell you the answer, but we will talk about it in class if you ask. Okay, so it's always available if you ask. So now we're looking at slope from a graph because we're doing slope and rate of change from a lot of different things, right? So we kind of want to know the change in y over the change in x here. What I like to do is start on the left side always, because if I start on the left side, the change in x is always going to be positive. So let me write that down. I mean, if you start on the left, this is just a little note, so maybe you want to write it down too. If you start on the left, the change in x will always be positive. So that's kind of nice. I like that idea because if I start on the left, then the change in x will be positive. So I'm going to start on the left, and I'm going to look at what's going on here, and I'm going to look at the change in y, which is here is going down. So I'm going to say the change in y is -1. And then the changes in x, going from the left to the right, is always positive. So that's 1, 2, 3, 4, 5. So this is the slope. It's down 1 over 5. So change in y over change in x. Okay. Let's look at the next one. Let's look at 2 and talk about change in y over change in x. I'm going to start on the left. So I'm going to start on the left side, which is this point. This point on the left is this guy, and the point on the left is this guy. Not necessarily start on the top or start on the bottom, just start on the left. It always helps. And now we can figure out change in y over change in x. So let's look at change in y, right? Change in y is up 2. So the change in y is 2 over the change in x. Change in x is 1, 2, 3, 4, 5, 6. 6 over, so 2 over 6. Now the thing is, 2 over 6 is a fraction that can be reduced, correct? So what would 2 over 6 reduce to? Think about that for a second. 2 over 6 would reduce to, that's right, 1/3. So we'd have 1/3 for our slope in this situation, and that's good. So I want you to pause the video and give number 3 a try. So take a second, pause the video, and try number 3. That is your now you try. So now you try. Now you try. Number 3. Okay, give that a try, and we will talk in a few. All right, well, we're wrapping it up there. That video is long enough for now, so I'll see you in the next video. Peace.